Okay, so we're now going to look at three key definitions for the topic. In the last video I mentioned, or I introduced the idea of enthalpy. So enthalpy is the total heat energy of a set of chemicals in a particular system. So if I added up the total heat energy of a group of chemicals of my reactants, I would have the enthalpy for that set of chemicals. So we're going to look at three definitions surrounding the idea of enthalpy. So I think we'll start with, so there's three here, you can read them yourself, I'll also read them, but we're going to start with the idea of standard enthalpy change of combustion. So triangle means change, so that's the change, the C stands for combustion, and then H is the enthalpy, and the circle with a line through it is the standard. So the standard enthalpy change of combustion is given that symbol there. Here's the definition for it. It is important. So the enthalpy change that takes place when 1 mole of a substance reacts completely with oxygen under standard conditions. So let's imagine I've got methane, so CH4, and the question says, write an equation to express the chemical change that takes place during the standard enthalpy change of combustion of methane. So it's the enthalpy change that takes place when 1 mole of a substance reacts completely with oxygen under standard conditions. So methane, 1 mole of methane is going to react completely with oxygen, and the products of combustion are carbon dioxide and water. And now I need to balance it, so I would need a 2 here, and then 1, 2, 3, 4, so I need a 2 here. So this equation now expresses the chemical change that takes place during the standard enthalpy change of combustion of methane, because we've got 1 mole of it, and it's reacting completely with oxygen to make my products. If we have another example, so let's say a question said, write an equation to express the standard enthalpy change of combustion of, let's do ethanol. So ethanol will be CH3, CH2, OH. 1 mole of a substance reacts completely with oxygen. So that substance is going to react completely with oxygen to make carbon dioxide and water. And then I need to balance it by making sure that the ethanol stays as being just 1 mole. So I'm going to keep a 1 there, I'm never going to change that. I need to make sure that stays the same. So I've got 2 carbons, 2 there, 6, 3 there. And then how many oxygens have I got? 1, 2, 3, 4, 5, 6, 7. There's 1 there, so I need 6 here. So 3 goes there. So that equation now represents the standard enthalpy change of combustion of ethanol. You can do it for any substance, but I've just picked to do those two. So that's the first definition. Second one, I think we'll do this one here. So delta FH with a circle with a line through it is the standard enthalpy change of formation. So the F is for formation, all the other symbols have stayed the same. So what is it? It's the enthalpy change that takes place when 1 mole of a substance is formed from its constituent elements in their standard states under standard conditions. So that's an absolute mouthful. I think it'll help us if we start to break it down. So let's say we were asked to write an equation for that expresses the chemical change that takes place in the standard enthalpy change of formation of, let's do it for methane again. So we're going to do one for methane, which is CH4. So 1 mole of a substance, in this case it's going to be methane, is formed from its constituent elements. So methane is going to be made from its constituent elements. So what elements have we got in methane? We've got carbon and we've got hydrogen. Carbon is monatomic, so it comes on its own. Hydrogen is diatomic, so it always comes in pairs as an element. So every time you find elemental hydrogen, it'll be in pairs. Every time you find elemental carbon, it'll be on its own. So those are the constituent elements in their standard state. So the standard state of hydrogen, if we have hydrogen in a room, it'll be a gas. And if we have carbon in a room, carbon's in your pencils, it's a solid. And methane is a gas. So the enthalpy change that takes place when 1 mole of a substance, methane, is formed from its constituent elements, carbon and hydrogen, in their standard states, there they are in their standard states, and then under standard conditions are done at 298 Kelvin, 100 kilopascals of pressure, and in this case we haven't got solutions, so we don't need to worry about concentrations. I do need to balance it, so if I put a 2 here, that finishes the equation. So let's do another one. Let's do for ethanol. So question says, write an equation that expresses the chemical change that takes place during the standard enthalpy change of formation of ethanol. So we're forming 1 mole of ethanol. And ethanol is a liquid from constituent elements. So what have we got in here? We've got carbon, we've got hydrogen, and we've got oxygen. Carbon again is monatomic, so it comes on its own and it's a solid. Hydrogen is diatomic, it comes in pairs and it's a gas. And oxygen is diatomic, comes in pairs and it is a gas. Just need to balance it now. So 2 carbons, 3 there, and I need to make sure that the number here stays, because we're forming 1 mole of a substance. I need to make sure that number there stays 1. So I'm going to put a half here to represent the 1 oxygen that is over that side. So standard enthalpy change of formation, standard enthalpy change of combustion, and then the final definition, standard enthalpy change of reaction. So R for reaction is kind of like a generic term for both of these. So the enthalpy change that takes place when 1 mole of a reactant is converted to products under standard conditions. So it's just a generic definition that could encompass these two. It could encompass other sort of enthalpy changes as well. Oh,